Okay, concept 7, graphs of polynomial functions. I know graphing is all of you guys' favorite thing to do. You just know it. You love it. Well, guess what? You're going to love it even more because it gets super fun with polynomials. So what we want to do first is we want to figure out all of the parent functions that we have, okay? We've done a couple so far. We've done linear and quadratic and cubic. And yeah, those are the ones we've done so far. So we're going to talk about a couple other ones including those, okay? So let me zoom in. So the first one we're going to talk about is a constant parent function. Basically what that looks like is it's a horizontal line. It's a horizontal line through some point on the y-axis. So we're going to call that y equals c, okay? C can be any number you want. So say this is 1. So if it was y equals 1, it would be a horizontal line through 1 on the y-axis. Okay? That's the constant parent function. The linear parent function we talked about earlier this year is y equals x. Okay? That is a line through the origin with slope of 1. It looks just like this. That is the linear parent function. All right? The quadratic parent function is y equals x squared. That's a parabola that hits 0, okay? The y-intercept is 0, the x-intercept is 0. It looks just like that. All right? The cubic function is y equals x cubed. And that looks something like this. It kind of reminds me of like noodle arms. Like if you've ever seen SpongeBob, how he kind of has noodle arms. I don't know, I'll do the dance for you during class if you ask me. So basically the cubic function goes up as on the first quadrant. So this is quadrant 1, 2, 3, 4. It's in the first quadrant and the third quadrant. Okay, it reminds me of noodle arms. I don't know why, but it does. All right. The quartic function kind of looks like the quadratic function. Quartic means degree 4. We learned that before. So it's sort of like a wider version of the quadratic function. So, and I'll talk about that later. That comes later, but it's just a wider version. Know that it hits this axis 4 times. This one hits it twice. It goes down and comes back up. That means it has a multiplicity of 2 at 0. This one has a multiplicity of 4 at 0 is what I'm trying to say. So it kind of actually does something in the middle that kind of does that. So. And then finally a quintic is y equals x to the 5th, and that kind of looks like the cubic, just a little bit wider, something like that, and it actually does something in the middle where it kind of does a little wiggle there too. So those are the 6 parent functions we're going to talk about. Anything after that, they're just variations of these 4 right here. Okay. All right, so let's talk about end behavior. End behavior is what happens on the ends of your graphs. What happens where the arrows are. Okay, we're going to look at and see where the arrows are. So I'm actually going to have you draw a little cross thing here that's going to mirror what we're going to put here. Okay, so end behavior, you look at 2 things. You look at the degree and the leading coefficient. You look and see if it's an even degree or an odd degree. So 1, 2, 3, 4, 5, even or odd. Then you look and see if the leading coefficient is positive or negative. These 2 things are what determines end behavior. That's all you have to look at when you're determining end behavior. Okay? So if you have an even degree and a positive leading coefficient, you're going to have a graph that does something like this. Okay? So this is like the quadratic parent function. My leading coefficient is positive and I have an even degree. So it looks like that. So basically, let's analyze that a little bit. As x gets bigger, or as we say, as x goes to infinity, my function also goes to infinity. It also gets bigger. So f of x goes to infinity. Okay, so that's how we write end behavior. Okay, we're also going to look on the other side. As x gets smaller, or goes to negative infinity, my function is still going to positive infinity. It's still getting bigger. All right, so that's end behavior for a positive leading coefficient and an even degree. All right, so let's do an even degree with a negative leading coefficient. Remember that negative means it gets flipped over, so that's going to look something like this. All right, so if I were to draw an imaginary graph through that, okay, as x gets bigger, or as x goes to infinity, my function gets smaller. It's actually going down. It's going towards negative infinity. So everything gets flipped around. Okay? And as x gets smaller and goes to negative infinity, my function also gets smaller and goes to negative infinity. All right? So that's end behavior for those two. We'll change colors here. Well, I'm going to do blue. All right, so an odd degree with a positive leading coefficient looks just like the cubic one. Okay, so again, if I were to draw a little imaginary graph through here, I'm actually going to do this for all of these. Okay, as x gets bigger, x goes to infinity, my function also gets bigger. My function also goes to infinity. So we're looking at what happens on the x-axis and the y-axis. Okay. As x gets smaller, we go back on the x-axis. My function is also getting smaller. It also goes towards negative infinity. This should be negative infinity. Okay. So with a negative leading coefficient, I just take this and I flip it over. So instead, it's going this way. And I'll draw my little graph again. Okay. So as x gets bigger with this one, my function is getting smaller. Okay, as x, not f of x gets bigger, negative infinity, my function is getting bigger. So everything gets kind of flipped. Okay, this is bothering me. X goes to negative infinity. And that's how you determine end behavior.